Okay, let me ask you. I've reorganized Schoology a little bit a couple times throughout the 5 weeks. Is it working for you now? Like, is it pretty, can y'all find everything okay? Okay. When we come in here every day, like I'm only going to see you once a week, you're going to be my first group of honors pre-cal. So you're the main ones that I'm going to actually record the video I'm going to upload for. What we're doing today in 2.1 complex numbers is pretty long. So what I may do to give you guys a break too, I may record for about 25-30 minutes and then pause it and let you guys practice some on your math lab assignment that's already up in math lab, and then I'll record the second half of it, and then I'm going to upload that video for everybody, for you, for my B1 class and B4. When you come in here every day, just get out your stuff, paper, pencil, you know the deal. And are you guys ready to be back at school? Are you excited to be here? No, not really. It's a lot different, isn't it? It's been interesting. Okay, in 2.1 complex numbers, do you guys remember last year in algebra trig using I, imaginary number I? Can anybody tell me what I is? Square root of -1. And mathematicians a long time ago, the reason they actually even invented an imaginary number system that has square root of -1 is so that they could actually obtain solutions for like x squared equals -1. Because of course, you know, in our real number system, you can't square a number and get a negative value, but in the imaginary and complex number world, you can. Imaginary numbers, and it's kind of hard to think about it this way, are actually used in electric current. There's an example later on in your notes that I get to and show you how that complex numbers are used in electronics. I had physics in college and we studied that, we studied electric current, how it runs through, and how it's actually implemented in that. And we're going to go over one example. But what we're going to do with complex numbers, we're first going to look at how to combine like terms with them, multiply and divide, add and subtract. Addition and subtraction is very easy. It's just combining like terms. Multiplication's pretty simple, and then divisions requires the most work. Then we're going to take that and look at how to solve quadratic equations that will get imaginary solutions. All right, so hopefully this will jog your memory from algebra 2 trig. The imaginary unit I is square root of -1, and so if you square I squared becomes -1. I'm showing an example in purple where you see the square root of -25, and that comes out in the imaginary world to 5i. But in a real number world, of course, square root of 25 would be 5. Or square root of negative 25, you would say, is not possible or no solution. But square root of negative 25, you can split into negative 1, and that's what comes out as I. And then square root of 25 is 5. So I is part of a complex number in the complex number system. And a complex number is written in a plus bi form. A is always your real part, and the part that contains I, of course, is your imaginary part. And this is in standard form. In your math lab, they're going to say write it in standard form and tell you to always put it in a plus bi form. A and B are both real numbers. If you can have a complex number that's only real where I would be 0i. But a plus bi complex number, that's what it looks like, and that's called standard form, where you write your real number part first, your I part comes second. So we're also jumping back up to the part in purple. We're also going to be simplifying radicals that contain negative values. So it's a little bit different way of thinking today. You're not going to say, oh, that's not possible. Okay, when you start adding, subtracting, multiplying, and dividing complex numbers with I, you have to know what powers of I are equal to. So it's a similar way as if I gave you x plus 2 and I said x is 3, what would you do? Like if I said simplify x plus 3 and you know that x equals 3. You just take and plug in, right? Okay, so let's look at, if I've got, we already know that I squared is negative 1. And that's based on I equals square root of negative 1, and us squaring that. What would I to the third power be? I to the third power would be negative I. Does everybody understand where that comes from? Every year when we start going through powers of I always have some that are rock and rolling with it, and then some that are like, I don't know where you're getting that. What would I to the fourth be? 1, because I to the fourth is I squared times I squared. And then we know that I squared was negative 1. So negative 1 times negative 1 gives you 1. Really, that's the most or highest power that you might see is 4, but there's actually a pattern. I have seen the ACT ask questions like, what is I to the 75th power? And so you can keep going, and all of these answers actually create a pattern and repeat. Like I to the 5th, tell me what 2 you could use to get I to the 5th. What 2 previous powers of I? I squared, I cubed. I squared is negative 1. I cubed, we already know, was negative I. So I to the 5th is what? Positive I. And then notice after the I to the 5th, it went back to I, so it's going to start back repeating. But like I said, I to the 4th and up, really the main one that you'll see is either I squared or I cubed. So know that I squared is negative 1. I cubed, if you see it, you're going to plug in negative I. All right, going back to this. I'll work these examples that are already worked in your notes for you. So you can just follow along if you want to and write these down. All right, we're just going to look at adding and subtracting first. Number 1, we've got 7 minus negative 9 plus 2i minus 17 minus I. Can y'all see that okay? Okay. All right, go through and distribute the negative signs that you see here and here. So 7 plus 9 minus 2I plus 17 plus I. And then just simply combine like terms. So distributing negatives, if you have multiplication, which we're going to see later on, you would do that first. So we've got the only powers of I, you've got negative 2I plus I, which make negative I. And then you have 7 plus 9 plus 17, which makes 33. Now, if they want you to write that in standard form, what would your final answer be? You would write your real part first, which is 33, minus your imaginary part, I. Okay, how do y'all feel about that one? Are y'all okay with that? All right. Okay, next, let's look at multiplying. Really quick, just to review from last year, can you mind tell me what these two binomials are called? Special case. Bonus points. Okay, they are difference of squares. And like if you actually FOIL them out, they will form difference of squares. And they're also known as what? Conjugates. Conjugates, you can shorten the full method down, but we'll talk about that later. All right, this first part, most of your math lab problems only have two binomials multiplied together, but this one has a pair multiplied, and then you have to subtract later on. So follow the order of operations in that sense. Okay, so let's multiply this first pair together. You have to use FOIL. So multiply your first terms, and that's going to give you 2. Multiply your outer terms, and you get what? Minus 2I. Multiply your inner terms, that gives you negative 3I. And multiply your last terms. Negative 3I times negative I gives you plus 3I squared. And what will we eventually plug in for I squared? Negative 1. All right, let's FOIL these. These are conjugates, so you only have to do what part of the FOIL method? Your first and your last. Can you might tell me why? Your middles cancel. So first and last, that'll give you negative I squared. Okay, let's go through and combine like terms. Your negative 2i minus 3i makes negative 5i. Plug in negative 1 for I squared. And then distribute the negative, so we got minus 9 plus I squared. And you can go ahead, of course, and plug in negative 1 if you wanted to up there. Then let's keep going, 2, and then that's going to make minus 3. So that's going to give you negative 1, and then 2 minus 3 minus 9 is going to give you what? Negative 10. And then you've got, this turns into negative 1. So minus 5i still left, minus 1, which eventually becomes negative 11 minus 5i. Okay, how do y'all feel about that? Good? How do y'all feel in the back about that? Good back there? Okay, before we look at division, we're going to look at simplifying radicals. Okay, so to simplify radicals that contain negative numbers, the negative sign always comes out as what? The easiest way I know to tell you is that the negative part is always going to come out and be as I. So negative part always comes out as I, outside the radical. You don't leave I inside the radical. We're going to go through and see if you remember how to simplify, for example, like root 12, and break that down. Okay, there you go.
So on AJ and BJ third block,
Mm-hmm.
you mark who accepted a lunch.
Okay.
So they can put in their numbers later. You just mark who got a lunch.
Okay, gotcha. Thank you.
They print them in not any order.
Okay. All right, number 3, we've got root negative 12. We're going to skip over number 3 in your notes, the other number 3. So this is technically, I guess, number 4. Root negative 12, root negative 4, minus root negative 2. But we'll come back to that in a minute. All right, can anybody tell me where you might start on this problem? Okay, you need to start and simplify every part. You cannot, this is very important, you can't multiply negative radicals together. You can't do that. You can multiply positive radicals together, like root 8 times root 9 would be root 72. But if I have root negative 8 times root negative 9, and I can show you the difference of why that comes out, but you can't multiply negative. So always simplify negative radicals before you multiply. So we're going to simplify root negative 12. The negative part is going to come out as I, Can anybody tell me how root 12 breaks down in simplest radical form? Two root 3. Do y'all remember that? And the i's outside with 12. I mean with 2. What will root negative 4 become? Two I. Negative comes out as I. Square root of 4 is 2. And then you can't simplify the square root of 2, but you can bring out the negative as I, but it's left as root 2. Are y'all okay with that? Does everybody understand where all that came from? Then after you simplify, you have to actually distribute, multiply them together. So you have 2i root 3 times 2i. That becomes 4i squared root 3. And then when you distribute I to root 3 to the last part, that becomes 2i squared. Multiply the outside parts together. And now we can multiply those radicals. I can say root 3 times root 2, and that will give me root 6. Four I squared out in front becomes negative 4. Still root 3. 2i squared. This all becomes positive 2 because I squared is negative 1. And then root 6. Can you add or subtract those? There's nothing, when you're adding radicals, you can't add those and say that makes root 9, like negative 2 root 9. You can't do that. They would have to be the exact same radical in order for you to combine them. So this would be your final answer. All right, we good? Okay, this, I want to go back to number 3, but before we do that, let's talk about what you do when you divide complex numbers. The first step is always to simplify the denominator. You have one late on into your 2.1 assignment in MATLAB, and I actually put in a tip. Simplify the denominator first if it needs it. Okay, the second thing, you need to multiply the numerator and denominator by the conjugate of the denominator. So multiply the top and bottom by the conjugate, and it has to be of the denominator. If you do it of the top, you're going to get the wrong answer. So multiply the top and bottom by the conjugate of the denominator. And you don't have to write this part unless you just want to. I'm going to show you why that is. Recall if I ask you to simplify 1 over square root of 7, what's wrong with that? You cannot leave a radical in the denominator, right? So what do we multiply the top and bottom by here? Root 7. So we get root 7 over 7. When you multiply the same radical to itself, those radicals cancel. If once again, you don't have to write this. If I ask you to simplify 1 over 2 minus root 3, what would you multiply the top and bottom by here? What's the conjugate of 2 minus root 3? 2. What goes in the middle of them? Plus? Since I'm going to answer wrong questions today, that's fine. This is going back to number 3 in your notes. It says evaluate, and it gives you x squared plus 19 over 2 minus x, and it tells you that x is 3i. So take 3i and plug in. Everywhere you see x, are we going too fast? Are y'all good? Are y'all following along okay? And 3i squared, this comes out to, you have to make sure you square both 3 and I. So 9i squared plus 19 all over 2 minus 3i. What do we do from that point? What will the top or numerator become? I squared turns into -1. You don't have to write this extra step, but just showing you in case some of you are still confused. I squared becomes -1. That makes -9 plus 19, 10. All over 2 minus 3i. Okay, from that point, we plugged in and simplified. The denominator did not need any simplification. What is our next step? Multiply the top and bottom by what? Well, I'm going to rewrite that so down here so you can see it better as we go through the whole process. Multiply the top. What's 2 minus 3i's conjugate? 2 plus 3i. Multiply straight across. So multiply 10 to 2 and negative 3i, you get 20 minus 30i. That's a plus. Was anybody gonna tell me that? Okay, on the bottom you have conjugates. So the only part you need to multiply of FOIL is what? First and last. So 2 times 2 is gonna give you 4. Negative 3i times positive 3i is gonna give you negative 9i squared. So the goal when you're dividing or when you have fractions like this, you want to make sure I is out of the denominator. You can't leave a radical, and that's what I is. So simplify further, the top is 20 plus 30i all over. The bottom becomes 13. That becomes positive 9. Are y'all okay with that? Okay, what MATLAB, you need to pay attention to this. MATLAB, I don't think they're gonna let you type it in like this. I think they're gonna make you split it up. But all you have to do is once you get it completely simplified, they want you to split that denominator up with both terms in the numerator. So for example, they want you to type in 20/13, your real part A, plus 30/13 I. But I'll accept, like if you're doing this on paper, of course, I'll accept either way. So these problems, they involve simple math, but just be careful with signs, just like I almost missed that sign. So be careful with signs. All right, how do y'all feel about dividing? Okay, last part, we'll look at one more and then we'll be done. Solving quadratics. You guys remember this awesome formula? Okay, there's a really neat thing that it's kind of more abstract and we don't tend to remember it. I have seen the ACT ask this question too. It'll ask for the discriminant value of a quadratic equation. What the discriminant is simply the b squared minus 4ac part, not including the radical. So it's just what's underneath the radical. If you compute that, it will actually tell you how many solutions are real and how many are imaginary. So for example, if you get b squared minus 4ac is negative, then there's no real solutions and you would have 2 imaginary solutions. Okay, when you're solving quadratic equations, what do you have to make sure it's set equal to? Do y'all remember that? And this is number 7, your notes, on page 3. So we have 3x squared equals 4x minus 6. And they asked me to solve for the roots or zeros or x-intercepts, which all mean the same thing, or find the solution. This has to be set equal to what? Has to be set equal to 0 always. So I always like to keep x squared positive. You don't have to. You should arrive at the same answer, but bring 4x and minus 6 over. So we get 3x minus 4x plus 6, or 3x squared. Okay, I'll go ahead and tell you, all of these in your homework will not, what's the easiest way to solve a quadratic if you can? What'd you say? What's the nice say? Okay, yeah, some people love the quadratic formula. I'm more of a, if I'll factor, I like to factor it, and then you just take each number and set it equal to 0. But most people like, hey, if I've got a formula and I got numbers, I can plug into a formula all day long. Quadratic formula, all of these will not factor in your homework. That's what the point I was trying to make. So you use your formula, x equals negative b plus or minus square root b squared minus 4ac all over 2a. What is the value of a? 3, and of course the value of b is negative 4, and c is positive 6. If you were to calculate the discriminant value, you would get a negative. But as we go through, you're going to see that anyway, easily. So b is negative 4. Minus 4 times a, which is 3, times c, which is 6, all over 2 times 3, which is 6. Okay, what do you get when you have 16 minus 12 times 6, which is 72? 16 minus 72. You get negative what? 56. And all right, while I'm here, let me make a quick point. I see this every year, and I tell students every year, what type of value always occurs after the radical? What type of value is it always? What sign will that number always be? Positive. I have students all day long that will say negative 4 and they'll say negative 16. So make sure that's always positive. All right, anyway, all over 6. And we have to simplify this radical. 56 will break down because most of your problems in math lab do not want a decimal. They want fractions. So we have negative 4 plus or minus. The negative sign comes out as I. And then can anybody tell me how root 56 will break down? Okay, root 56 will break down into 14 times 4. You want a number that you can take the square root of, which is 4, of course, and then you want a number that you cannot take the square root of and also doesn't have any perfect square factors. Some of you may be thinking 7 and 8, and then 8, of course, would break down into 4 and 2, so you can manage that route. So the square root of 4 comes out as 2, and then you leave root 14. Okay, now for the fun part, that it just keeps going, it seems like. Will this simplify further, or how would you check it? This is what Math Lab wants you to do. Notice you've got, of course, 2 answers. So one of them is negative 4/6 plus 2i. Let's slide that up for you. Negative 4/6 plus 2i root 14, and that's over 6 as well, comma, negative 4 minus 2i root 14, and each of those are also over 6. Tell me what parts will simplify one more time. Or what we didn't simplify, we split it up. But how will it simplify? Negative 4/6 reduces to negative 2/3. Your 2/6 part reduces to 1/3. You can write 1i root 14 if you want to, but you'll never see that. But MATLAB should still count you correct if you do that. Now, I'm okay if you get down to this point and I didn't specifically tell you to simplify it and you got here, then you're good. But if it tells you to simplify it, then negative 2/3 plus or minus. And I'm not going to make you split them up either if you were doing it on paper. Okay. Okay, go ahead, work on your 2.1, practice some. And if you run into any questions, just raise your hand and I'll come to you. Or you can come up here. Yes.
Okay, so you could be negative 4 to b, this be minus b as part of the equation, so we can become positive 4
Where are you at?
in the very beginning.
Oh, yeah. Yes, thank you. Thank you for pointing that out. All right, negative 4, so positive 4, positive, positive. It's going to make those 2/3 become positive all the way down. Thank you. Does everybody see that? Change all your 4s in the front and all your numbers in the front to positive.